Hey guys, we're now going to graph a system of linear inequalities. So basically it's where you have two inequalities, they're grouped together with this symbol and you're going to put them both on the same coordinate plane. Okay, so how you go ahead and you graph these is you would graph them individually and then you're going to look and see where they're both shaded in. Okay, so if I'm looking at my first inequality, y is less than or equal to x plus 2, that's in slope-intercept form. So I'm going to start with the y-intercept of 2, and I have a slope of 1, so I'm rising 1 and running 1. Rising 1, running 1. I could continue that if I wanted to. And again, I'm going to check to see if it's a solid or a dashed line. Because it's or equal to, it's a solid line. Okay. Again, I'm making sure that I'm going all the way through the coordinate plane. Okay. So extend that a bit. Again, if my line's not perfect, not entirely worried about it. Okay. Now that I've graphed, I'm going to make sure I have arrows on each line. I'm going to make my line a little thicker. Okay, in this case, I could color code these if I wanted to. I could make my first line blue, my second line another color, up to you. Okay, it's a solid line, so I'll make sure that solid is selected. Okay, so again, now I need to decide where to shade. So y is less than or equal to. So I can always test a coordinate point. I can test 0, 0. Is 0 less than or equal to 0 plus 2? So that would be 0 is less than or equal to 2, which is true. Okay, again, that's part of the solution, so that means I'd want to be shading below. Another kind of little shortcut is if your line is in slope-intercept form, usually you can kind of read the inequality sign. So less than would be below, greater than would be above. This doesn't always work when your equation is in standard form, so testing a point is a foolproof method that will always work. But again, you can kind of double check if you want, if it's in slope-intercept form. So I'm shading below. So I'm going to go ahead and select my polyline tool. Okay, again, I'm going pretty much all the way on the line. Oops, I don't like the way that came out, so I'm going to hit undo and start over. Again, I'm selecting the entire area below this line. Once I get that, and I know I'm going to be graphing two different lines, so I like to usually choose something like blue and yellow. That way, when I see the overlap, I know that it makes green. So there is my yellow. I like that. Okay, now I need to go ahead and graph my second line. So again, this is in slope-intercept form. I have a y-intercept of 5 and a slope of -1/2. So from here I go down 1/2. That's enough for my line. Again, it's going to be a solid line. Okay. I'm making sure to go through the entire graph. I'll make this line a different color. Not that it really makes a difference, but I have the option, so I can. So there's my line. Again, I need to test a point. So 0, 0 in this case would be below the line. I like to test 0, 0. So if I plug in a 0, -1/2 times 0 is 0. So 0 is less than or equal to 0 plus 5. 0 is less than or equal to 5, which is a true statement. So I would want that in the shaded section. So I'm going to be shading below. So I'm going to select my polyline tool. Again, doing the same process along the line, shading everything below. Okay, and I'm going to do blue. Okay, So now what I can see, okay, is the area that they're both shaded is where it's green for this whole area. So that means that this, any points in this green shaded area would be a solution to this system. So I need to state a coordinate that is a solution. I could state anything here. Now 0, 0 is a nice one because I've checked it algebraically, but I don't just need to pick 0, 0. 2, 0, 4, negative 2. Any of these points in this area would be a solution. If I want to choose a coordinate point that's not a solution, I could really choose anything that's not in the green area. Okay, now something that hasn't been shaded at all is kind of an obvious non-solution. So I could say 0, 7. Okay, but I could really choose anything in any of the areas that's not in the green. Because remember, a solution to the system has to be a coordinate point that is a solution to both inequalities. So there's no really one answer that we're looking for here, because inequalities show us an infinite amount of solutions. There really can be an infinite number of answers that you could be typing in these boxes.